Okay, we're getting near the end, folks. So I'll do sum of 5.2. After I think I've done enough, I'll give you the quiz. And then, yeah. Okay, so we're aiming for 12 quizzes total. So one here, one next week, the day before Thanksgiving. Friday the 4th, and that'll be our last quiz. Okay, so again, for now, I'm aiming for the last exam to be the 10th of December, although I'm not promising I'll get it back to you the very next day. But, you know, the nice thing about this kind of situation is I could send it over the weekend, you know, just like I've been doing. I want to reserve at least one day for questions and answers. Okay, again, our final exam is Wednesday the 16th, 11:10 to 1:40. Okay, so I'll introduce sum of 5.2, which is not that much different from 5.1. Some notation that you have to get used to, although you've sort of already seen the notation. Okay, and then after a certain time, I'll stop and give you the quiz. All right. Okay, so 5.2, we're doing something called the definite integral, which seems to imply there's something called an indefinite integral, and that's correct. Okay, the stuff in 4.9, that was called indefinite integrals. You don't have to write it down, and I'll emphasize that a little bit later also. But definite integral. Let me show you the notation. Now, they actually give us a definition. I don't want you to worry about the definition too much. Okay, so don't get scared by all this other extra stuff. It's true, it's correct, but I'm just giving you what you need. Okay, there's that integral sign that I did in 4.9, but there's a number here and a number here, f of x dx. So f of x dx, that looks like stuff we did in 4.9, but they're going to give us a number here, a number here. The way we read this is the integral from a to b of f of x dx. Okay. Now, what's all this stuff mean, right? So I'll talk about that. Okay, first thing I want to notice is one big difference between section 1 and 2. Section 1, all of our functions were positive. Okay, positive, above the x-axis. Above the x-axis. Or when they give me a table, they were all positive, right? There were no negatives anywhere. Right? All positive graphs. Positive graphs. Okay. Now we're going to allow for some negative graphs. Take a look at this. Okay, so we're going from 0 to 3, and we chop it up into a whole bunch of pieces. We said base times height. Well, some of these heights are negative. So if the heights are negative, then that means when I add these up, I'm going to get negative values. So everything that's in yellow would be indicated by a negative value, and the blue ones are going to be positive, right? Because strictly speaking, when I say a height, I'm talking about the function value. So now some of the heights might be negative, a depth, if you would, D-E-P-T-H, we're going down, right? So if I have my delta x, right, the delta x is going to be whatever, and the so-called heights are sometimes going to be negative, like this looks like maybe -3 or -4. So when I do base times height, so-called, they might come out to be negative. Okay. All right, so now what do we mean by this symbol? Okay. So let me illustrate this. Page 379. Figure 3 is a good picture for this. All right, so I want an approximation for the integral from a to b of this function. And notice if they decide to chop it up into so many pieces, this is going to be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 pieces. Chop it up in 12 pieces. Okay. And then you do base times height, base times height. Some of these are going to be negative, right? So this one's positive, this one's positive. Those rectangles are above the x-axis. But notice these rectangles are below the x-axis. They'll be indicated by a negative. Okay. The integral from a to b of f of x dx is the net area. Okay, we're referring to the true value of this area plus this area minus this area. This is counted as a negative because we're going down. We're going below the x-axis. Okay, so that's the idea of a definite integral. So the integral from a to b of f of x dx, you notice it's the same notation as I used in 4.9. In 4.9, we didn't have any numbers here, right? It was just integral of f of x dx. Then you know what it means. Anti-differentiate, blah, 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 and put plus c. And you'll be doing that for the quiz. Here, we're asking for the true value of the area bounded by the curve and the x-axis, where anything above is counted as positive, anything below is counted as a negative. Yes, and at first sight, you might say, that's crazy. Why do we have two different meanings for apparently the same symbol, right? The same symbol, same notation. If I don't have the a and the b, then it's going to be anti-differentiate plus c. If I do have numbers here, we're talking about an actual exact value, which we don't know how to get right now. Okay? Exact value of the area bounded by the function and the x-axis, where anything above is counted as a positive, anything below is counted as a negative. Okay? So it doesn't make sense right now, but don't worry. By the end of the course, we'll tie it all together. Okay. So just some pictures here. So a big difference is we're going below the x-axis sometimes, right? So if I chop this up into so many pieces, this is 1, 2, 3, 4, 5, 6 pieces, and I go base times height, well, some of the heights are negative, right? So the yellow ones are going to be negative, and the positive ones they have in blue. Okay? Same concept here. They chopped this up in a whole bunch of pieces. Okay? R40, we know what that means. Use the right endpoints, chop it up into 40 pieces, and as you can see, there's a whole bunch more that's negative than positive. So it looks like our final answer should be a negative quantity. In fact, R40 comes out to be negative 6.399. It looks like it's going to be about negative 6.4 for the true value, right? And then they chopped it up into 5,000 pieces, did it on a computer, got negative 6.7473. So my guess is maybe negative 6.75, all right? Okay, that's the only real difference between section 1 and section 2. This notation, the integral notation, so the integral notation refers to the exact value. It's a theoretical construct for now. It's the exact value of this area plus this area minus this area. So the only other new thing is that we're going down sometimes. All right. So I'm ready to start. So what do we got here? 1, 3, 5, 6, blah, 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 blah. Okay, so we'll do some today. We can do some next Monday, maybe even Tuesday. We have time to do all this stuff. So let me get started with something. So 5.2, number 1. Let me get that here. Okay, evaluate the Riemann sum. What is Riemann sum? Okay, when you're doing a base times height, add them all up, that's called a Riemann sum. So last time you were doing Riemann sums without even knowing it. Okay, so Riemann, R-I-E-M-A-N-N. Okay, so when you go base times height, add them all up, that's called a Riemann sum. So don't worry too much about the notation. Let me see where I can find stuff. Evaluate the Riemann sum. F of x is x minus 1, negative 6 less than or equal to x, less than or equal to 4, with 5 subintegrals. Take sample points to be right endpoints. And explain with the aid of a diagram what the Riemann sum represents. Okay, so what is this Riemann sum stuff? Okay, so we're estimating the integral from negative 6 to 4 of x minus 1 dx. Okay, so from negative 6 to 4, that's 10 units, right? Chop it up into 5, so delta x is 2. So here's the picture. x minus 1, that's easy. Slope is 1, y-intercept is 1. Going like that. Okay, so chop it up into 5 pieces. Delta x is 2, so -6, -4, -2, 0, 2, and 4. So there are 5 subintegrals. 1, 2, 3, 4, 5. Okay, and we can figure out all the heights. The function is x minus 1. So -6, -7, -4, -5, -2, -3, right? Whatever x value is, you just take away 1. 0, -1, 2, 1, and 4, 3, right? Okay, so R5, so base times height, but a lot of these heights are really depth, they're going down. Right? That's going to be negative. That's going to be negative. That's going to be negative. This one, the right endpoint is going to be positive, and the last one's going to be positive. But it definitely looks like there's more negative than positive. Okay, so base times height, which is a depth, base times height, base times height, base times height, base times height. But all the bases are 2, so factor out the 2. And now they want the function value, it says, at the right endpoints. Okay, so the function value at -4 is -5. Plus the function value at -2 is -3. The function is just x minus 1. Just subtract 1. Plus the function value at 0, -1. So these 1, 2, 3 rectangles are all going down. So they'll be indicated by a negative value. Then the last 2 are positive, just like last time, right? The function value at 2 is 1. So that's the 4th one. And the function value at 4 is 3. Okay, so they told me to use the right endpoints. Right? So that's what I did. Sample endpoints to be right endpoints. So this Riemann sum is our approximation for the true area bounded by the curve. In this case, the curve is a straight line. Okay, bounded by the curve and the function and the x-axis. Add them all up. Very convenient. Looks like all of these cancel out, right? -3, +3, -1. So it's just 2 times -5. So -10. And so it looks like it's -10. Okay. That's it. Okay, I was going to show you number 9 without actually graphing it because it's a difficult graph. Number 9, use the midpoint rule. Okay. Integral from 0 to 8 of sine radical x dx n equals 4. Okay. When I use that symbol, it's theoretical. We're saying theoretically give me the true value of the area bounded by the curve and the x-axis. Right now, we only know how to approximate. So use midpoints, n equals 4. Okay, I'm not going to try to graph it. This is not an easy graph. And by the way, it's not even periodic. This is not a periodic function, it turns out. So we're not even going to try to graph it. Okay, so from 0 to 8, chop it up into 4 pieces. So delta x is again 2. They said use the midpoint rule. So the 4 midpoints are 1, 3, 5, and 7. And yes, there's some graph above or maybe below. We don't care. I'm not going to try to graph it. But you don't have to. You can just plug directly into the function. Right? They told us to use the midpoints. So between 0 and 2, 1 is the midpoint. Between 2 and 4, 3 is the midpoint, and so on. So I'm going to plug in these guys. Okay? So when I do base times height, base times height, base times height, base times height, the bases are all the same. They're all 2. That's my delta x. And then I want the function value at the midpoint. So f of 1, f of 3, f of 5, f of 7. So I plug in these 4 numbers into here. So 2 times sine of square root of 1 plus sine of square root of 3 plus sine of square root of 5 plus sine of square root of 7. These are all in radians. So if you're punching it out in your calculator, make sure that you're doing it in radian mode, not degree mode. Okay, and you'll get your answer. I don't even know which of these are positive or negative. Okay, I'm pretty sure that one's positive. That one's positive, but just barely. And I think that one's in quadrant 3, so that's probably negative. But it doesn't matter, and who cares, right? So punch it in a calculator, 6.1820. That's my answer. Okay. All right. The only other one I was going to show you was a setup for 6, but that might take a while still. So 5 and 6 are similar. Let's see, 5 and 6 are on our assignment. Okay. 5 and 6. Right, so I should show you the even one, number 6. So 5 and 6, they give you a graph. So there's a graph for 5, and there's a graph for 6. So I'll show you 6, and this is kind of awkward again. I have to write kind of at the same time as I show you the text. Okay, so some of the times it's negative, sometimes it's positive, and I have to be a little bit careful here. The way they've got this set up, each one of these squares is 0.5. Is that right? Okay, that's 1, right? But there's 2 squares, so that's a half. And likewise up and down. So each one's actually 0.5. So that's -1. That's -2. To, I'm guessing that's 4. 1, 2, 3, 4. Right. So it's the whole graph. I'm going from -2 to 4. Okay. 6 subintervals. So if I'm going from -2 to 4, how far is it from -2 to 4? 6 units. 6 subintervals. That's very nice. That means delta x is 1. All right. All right, right endpoints, left endpoints, and midpoints. All right. So I want R6, L6, and M6. So it's going to be base times height, and so on. But don't forget, some of those heights are really depths. You're actually going down. Okay, so have to be careful again that each one of these is 0.5. So we're going from -2 to -1, -1 to 0, 0 to 1, 1 to 2, 2 to 3, and 3 to 4. All right. So R6 is delta x, which is 1. And then the function value at all the right endpoints. So the right endpoints are starting at -1, right? If you go from -2 to -1, we're chopping it into 6 pieces. So it's f of -1, f of 0, 1, 2, 3, and 4. So f of -1 plus f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4. Okay, and now I have to read them off. So the function value at -1 is -1.5. Keep in mind, each square is a half. There's 3 of them. F of 0 is 0. F of 1 is 1.5. F of 2 is 0.5. F of 3, 1, 2, 3, down here, which is -1. And F of 4, 1, 2, 3, 4, at the very end, so that's 0.5. Okay, these cancel out. These cancel out, 0. I'm going to say R6 is 0, right? These cancel out. 0.5 plus 0.5 is 1. 1 minus 1 is 0. So our estimate for the true integral is 0. Might be. I mean, it looks like you have quite a bit below here, and then quite a bit above, and this tiny piece above also. Okay, L6. I do the 6th left endpoints. Okay, so the left endpoint here is -2. For this interval, it's -1, 0, 1, 2. And the last interval, which goes from 3 to 4, I pick 3. So 1 times, essentially what happens is that you throw out f of 4, you keep all these other guys, and you put in f of -2. So f of -2 plus f of -1 plus f of 0 plus f of 1 plus f of 2 plus f of 3. Okay, so there are 6 left endpoints: -2, -1, 0, 1, 2, and 3. Okay, well, these 5 I can just copy. So I'll just peek up here and copy these: -1.5, 0, 1.5, 0.5, and -1. Multiply by 1, but of course, if you multiply by 1, it's easy. Okay, so f of -1, that matches, that matches, that matches, that matches, that matches. So the only new one is f of -2. So -2, 0, right? Okay, so add these up. Let's see, these cancel out, right? So that is -0.5 times 1, so -0.5. Okay, and then M6, I do all the midpoints. Again, your bases are still going to be 1. How come? The distance from -2 to 4, which is what I'm trying to estimate the integral from. Okay, that's still 6 units. I'm chopping it into 6 pieces. So all the bases are 1. Now I need to function evaluate all the midpoints. Okay, so that is going to be -1.5. Okay, -1.5. Then from here to here, it's -0.5. And then +0.5. And then 1.5, 2.5, and 3.5. Okay. The last interval goes from 3 to 4. What's the midpoint? 3.5. The first interval goes from -2 to -1. What's the midpoint? -1.5. Okay. Unfortunately, this time none of those are duplicated, so they're all brand new. Okay, so I have f of -1.5 plus f of -0.5 plus f of +0.5 plus f of 1.5 plus f of 2.5 plus f of 3.5 equals 1 times. Okay, so these are all brand new. I have to read them off. So -1.5 is -1.5. F of 0.5, here's 0.5, -1. F of +0.5, that's 1 square, 1. F of 1.5, remember each square is a half, so 1.5, we're there, 1. F of 2.5, 1, okay, let's see, that's 1, that's 2, this is 2.5, 0. And finally, f of 3.5, where's 3.5, let's see, 1, 2, 3.5. I'm down here, so -0.5. Okay, so how should I do this? These two cancel out, right? Cover it up. Let's see. Okay, -1.5, -0.5, that's -2 plus 1, so -1. I'm going to say it's -1. All right, so that's using left endpoints, right endpoints, midpoints, and so on. All right, that was pretty much it, folks. I was going to stop there. I know some of you may have put something in the chat, so let me get that. Otherwise, we're just about ready for the quiz. I don't know why it's yellow right now. So let me stop the share, check the chat. Okay. All right, so all right, so Prasanna left something, you can see what he has there. And that's that. Okay, question, isn't the y for negative 1.5 negative 1? Okay, I may have looked at it wrong. I'm guessing you're talking about the last one. So let me see that, but otherwise that's it. So it's f of negative 1.51. F of negative 1.5. F of negative 1.5 is negative 1. And what did I write for negative 1.5? I looked at the wrong thing. Yes, you're absolutely right. Okay, so thank you. Good catch. I goofed. This should have just been negative 1. Okay, so I'll make it look like 1.0. Who's that? So that's going to make that negative 0.5. So I go like that, and it doesn't look like I made a mistake, right? Learn how to cover your mistakes, so to speak. Okay, right. So negative 0.5. And I think I caught up with the chat. Let me see if that's correct. Yeah. Okay. Okay, quiz time. So as usual, get your cell phone cameras out, and then I'll set you up in your breakout rooms. Here we go. So find the antiderivatives. So all your answers should be blah, 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 plus C. I'll read it also for you if it helps. Number one, integral of 1 over x minus 3x squared plus 2e to the x dx. Number two, integral of 10 to the x plus 4 over radical x dx. I actually didn't talk about some of these, but think about going backwards from the derivative, right? You say, okay, what did I do for the derivative? I did blah, blah, blah. So you have to go backwards. Okay, 3, 4 over radical 1 minus x squared plus 6 cosine of 2x dx. Okay, so a couple of them you have to think of the chain rule in reverse almost. Okay, so I'll assume that everybody has it now. And again, worst comes to worst, it's on the video. We're still being recorded, so you can check the video. Okay, so get started with it. Let me set up your breakout rooms. Again, if your breakout room ends up with too few people, I might end up moving you. And then have a good weekend. Okay. So let me set this up. I'll